Are you ready?
No. Etienne just needs paper from me.
Okay. So what we did Friday was graphing. Today we're going to do solving, and we're going to do solving in a bunch of ways. We're first going to do graphing by hand. Which means non-calculator. Then we're going to do graphing on the calculator. Then way down here in example 4, we're going to do algebraically. So graphing no calc, graphing calc, algebra. How many ways are there to solve an absolute value equation? Graphing by hand, calculator, algebraically. 3! 3.
Yeah. I almost did too.
Graphing by hand, so no graphing calculator.
I haven't attached the
I know, but it's okay. This will be okay. Graph the left-hand side. If you don't like my abbreviation there, then you can write it out in full left-hand side. Step number 2, graph the right-hand side. By graphing the two sides independently, what we're actually doing is making a system of equations, and a solution to a system of equation is where the lines cross. So you're going to mark the intersection points. And then you're going to write down the coordinates.
It's so loud last night. I couldn't scream. I don't press play. I only come to this area. It's tired. I believe so.
So what we're really going to do is split this equation into two pieces. I'm going to take y equals the left-hand side, which is just an absolute value graph. That's what we did Friday. And then separately, I'm going to graph y equals the right-hand side, which is just the number 5. So this is a good review of what we did Friday, is how do I graph the absolute value of x plus 3? Yeah, so ignore that absolute value and graph the line. How do I graph a line x plus 3? Yep, the y-intercept is. Slope is. Why am I doing in pencil right now? And why do I have to erase part of it? Yeah, because anything under is going to flip up.
Yeah. Same here. Ooh, that's weird. How many? 4.
And so what's going to happen to this part that's under the x-axis? It's going to flip up at the x-intercept. That's something my mom would say. How do we graph y equals 5? So what do we do when it's just a number? It's not a line. It's not a quadratic. What do we do? So y equals a number is one of your special lines from last year. All lines are straight. What do we call this? Horizontal. So we go to where y equals 5 and just draw a horizontal line right through. And again, what we've done by splitting the equation is made a system of equations, and a system from last semester is where the lines cross. So we've got a point approximately there and approximately here. And so let's estimate those points, the one on the left. -8 and 5. And 2 and 5? Mine's a little bit off on the right, but I think most people have it at 2 and 5. That's it. That's solving the system. That's it. Well. Let's do the same method, but let's do it on the calculator. Oh, yeah, use.
So to graph the x plus 3, so then 3 for the y-axis, then up 1 and up 1 and over.
So you did systems of equations already last semester on your calculator, so just a refresher. y1, we're going to put the left-hand side. y2, we're going to put the right-hand side. What's the button that we press when we want to calculate anything on a graph? So we've used it probably 100 times so far this year. Second function, calc. And so I'll do it here. What do you think on that menu might have to do something with what we're talking about? Intersect. So 5, intersect. And you might just have to repeat that if there's more than one intersection point. Okay, so this isn't necessarily for absolute value. This is for any kind of systems of equation, that method. The one thing you do need to know is where to find the absolute value notation in your calculator. So it's called ABS for obvious reasons, nothing to do with the brakes of your car. And to find ABS, it's under the math menu. And then I'm going to tab right to num, which says number. And, whoa. Is that under your math menu? And I'm going to tab 1 to the right, which is the number menu.
Wait, so what are we doing?
Third time, I'm going to hit the math button. I'm going to tab right to the number menu. And I would pick number 1. Okay, so math button. Tab 1 to the right for the number menu. And then you're going to pick number 1, ABS. So go into your y equals, clear out any crap that might be in there. The left-hand side is going to go into y1, so I need to start with the absolute value notation. Where is it?
That is here.
Math. 1 to the right. Pick number 1. Okay, so it can't draw those straight lines. It'll just put ABS. Now we're going to do negative x squared plus 2x plus 5, and then close off the absolute value.
I just got like 2 lines.
You might, if you've got the new operating system, you might actually get the lines. Yep, just put them right in between. If you have this system, yes.
And then for the other one, we just press 2.
And then I'm jumping down to y2 and putting in the right-hand side, which is just 2. So we're doing exactly what we did last example. We're just not doing it by hand. We're letting the calc do the work. And then we always go to zoom, and what's our default that we pick? 6. Oh, how cute are you?
There's like 4 intersections.
There are 4 intersection points.
We do that 4 times.
So let's just do a quick little sketch of what we see. It doesn't have to be exact.
I'm a little behind.
So something kind of like this.
Doesn't, what am I talking about? I like the animation when it does the thing. It's like when you grab it.
You could even make the rollerball graph it. For no reason. Does nothing.
Yes, doing that next
Why
time.
is it even there?
The animation is even could be even better with the volleyball. I'm doing that next time.
Just try to make math fun. And
Not that it
games.
isn't fun already.
Exactly. Good job.
We have game trivia.
Everyone's caught up to the graph?
And
I'm so taking down.
university exams, they make it clear thing 100% you lose your games.
There's no calculators at university math exams.
Well, what Mr. T said, Mr.
There's no calculators.
He said he had
Maybe physics and chem, not math for sure. They're all non-calculator.
Because you will get cheat.
Okay, so second function calc.
Yeah.
Number 5.
Told me this before. As soon as you get into university, you're doing math course.
And typically what happens is it plunks the little cursor on the y-intercept. I'm going to go all the way to the left intersection point just so we find them in order. So I'm just hanging out somewhere near that first intersection point. This isn't left bound, right bound. You just need to be somewhere around it. And it's asking you first curve, and you're going to hit enter. And what happened, and you may not have noticed, is the cursor has actually jumped to the Y2, and it's asking you, is this the second curve? The reason it asks you that is sometimes you have 4 and 5 different graphs, and so they're asking you which are the 2 you want me to use, and you're going to hit enter. And then it always says guess, which means nothing, and you're going to hit enter. Bam, there's the first point. So the one on the far left would be negative 1.8 if we round to 1 decimal place, comma 2. I'm going to repeat that again, second function calc, number 5. And I'm just going to come somewhere close to the second intersection point, so just hang out somewhere near that second one. Again, it's not left bound, right bound, you just have to be close to it so the calculator understands. Enter once, enter twice, enter 3 times. The second one is? Third time, second calc. Number 5. Hang out by the third one. And again, there's no particular spot you need to be, just close to the third one so the calculator understands. Yep. Enter once, enter twice, enter 3 times. The third one is? Why do these all have the same y value? Yeah, because 2 is the second graph, so they're all going to have that. And how do we find the last one? Second calc. Number 5. Go somewhere by the fourth one. And the last one is? And that makes sense because it's symmetric, so that's why there's a pattern going on there. There's graphing by hand, there's graphing with a calculator.
I think I screwed up.
Okay, maybe you can ask someone sitting around you.
I got 2 intersections. I got the same. I got the same one the second.
That just means you didn't move close enough to the next one.
Well, I'm not entirely sure which one I was moving towards in the first place. I thought I was moving towards the one on the bump that I printed wrong.
Do you want to practice by hand or practice with the calc? Okay.
Now I've got to confuse myself.
Okay, practice number 3 with the calc.
Good. It's all right. You're wrong.
Step 1, create 2 equations.
Okay, cool. Well, then I retract my earlier statement.
Create 2 equations, one with the positive absolute value and one with the negative absolute value. So do you remember where we wrote the piecewise function? We took the thing in absolute values, made it positive, and then we took the thing in the absolute value, made it negative. Same deal.
That's just something inside.
Yep. Mhm. Solve both. Waiting. Step 3. You must. And I'm going to underline it 500 times. Because I already wrote it. You must check your solutions. These equations can have what's it called when you check it and then it turns out it doesn't work? Extraneous roots. So that is 3 kinds of equations we have seen so far this year that can have extraneous roots. What are the 3 kinds? Okay, so absolute value. Yes, good logic skills. Radicals from Unit 2.
And then the, oh my gosh, what the heck was last unit?
Rationals, which was Unit 7. You're going to meet 2 more in grade 12, and then you're done with extraneous root questions.
After these 4 questions, are we done with the thing today?
For today, yeah.
And we have one more time?
Yep. Go into paper. Go back. Go back. Go back.
Yeah, which means 7 days for her, which also means 10 days to be in school. Yeah. What? 10 more classes. Okay, like, no, 10 more classes. Yeah. June 11th is not the 11th.
This is the 3rd.
Yeah, June 11th.
I said 10 days.
So for these ones, I like to use a Mr. Squigs to remind myself that we're actually going to have 2 different equations. If you don't do that, what happens is you're just going to end up solving the positive, and you're going to forget about half of the solution that you need to do. We're going to take what's inside the absolute value and make it positive. And we don't usually write that plus. I'm just showing you for the first one mathematically what we're doing. Or we might have had something negative that ended up in a value of 2. Okay, so I took exactly what's in the absolute value, I put a positive in front of it, and I put a negative. Now I'm just going to solve it like an everyday average normal equation. So when I get rid of that negative, this is x minus 3 equals 2. X equals, oh my, 5.
Yep, very easy.
The other side, I'm going to distribute the negative. Yes. Yes. So negative x equals negative 1. X equals 1. Now we check. And I'm just going to go back to the equation with the absolute value with everything that's there, and I'm going to put in the 2 values for x. Okay, you have to make sure to keep that absolute value so you're not going back to the top of this right-hand side, you're going back to the question. Okay, so not just to here. Absolute values work like bed mass, they work like the bracket, so we're going to do what's inside first. So 5 minus 3. And what's the absolute value of 2? So how many units on a number line between 0 and 2? 2 equals 2, what does that mean? Good to go. Happy solution, everything hunky-dory. Inside the absolute value first, so 1 minus 3. Absolute value of negative 2. 2. Conclusion. Good to go. So 2 solutions for this one, x equal to 5, x equal to 3.
Is there a word for 2 solutions or like a?
No.
Actually, if you were trying to do it in Spanish, it would more likely be soluciones, but I don't even think that soluciones is the actual Spanish.
It sounds Spanish, though.
I'll look it up. I'll look up the actual. I'm in Spanish class. I take Spanish. How about I look up the actual Spanish word and I'll get back to you tomorrow on that. How does that sound? Remind me. I'm gonna forget. Well, somebody who thinks I'll remember remind me.
Going to set up the 2 equations. All I care about is the absolute value. I'm not going to touch the right-hand side on either of these equations. It's going to stay as is. So I'm going to put a plus in front, which really just means I'm writing what it is without the absolute value. Notice the negative y plus 4 just tagged along. The other equation, I'm going to take what was in the absolute value and put the negative in front of it. And the minus y plus 4 just tagged along. Why didn't I change the sign on the right-hand side? Because it doesn't have the absolute value. It's got nothing to do with an absolute value. It just is what it is. Okay, this one is just a straight up linear equation. How do I get minus y to the left-hand side? How do I get rid of the minus 1 to the right-hand side? Y equals? Yeah, let's check it right away and do some fraction work. No, let's do it. It'll be fun. It goes wherever y is. Now let's do it. Under the 2 is a little imaginary one that we don't see. How am I going to multiply those 2 fractions together? Not for multiplying. Top times top, bottom times bottom. So 2 times 5. Imaginary 1 times 3. Now I need to add and subtract on each side. How do I add and subtract fractions? This is where we use the common denominator. 3 and imaginary 1. First fraction is not going to change, 10 on 3. Second fraction is going to become? Now subtract 10 thirds minus 3 thirds. And let's do the right-hand side. Still a common denominator of 3. First fraction is not going to change, negative 5 on 3. Second fraction is going to become? Y12. Add them together is going to give us? And I'm out of room, but we need to do the absolute value of 7 thirds is? So 7 thirds equals 7 thirds. Conclusion! Yay! That's as hard as they're going to get non-calc. So some simple fraction work. That's adding and subtracting.
It's just annoying. 'Cause you're like, oh, always not.
I know. But if we didn't have fractions, we couldn't share pizza. Okay, this side, what do we do? Yep, so distribute the negative.
Negative 2y plus 1 equals y plus 4.
How do I bring the minus y over to the left? How do I bring the plus 1 over to the right? But we're not done. So negative 6 minus 1.
Okay, so then it'd be negative 7 plus 1. 7. Which means 7 equals 7. Wow.
Why is there a double negative like that?
Why was there a double negative here?
Because it was a negative in the first equation, and it's negative 3.
So negative negative 3 gave us positive 3.
Double negative is equal to positive. That's not fun.
Friend to friend, try number 3 together. How many ways are there to solve a quadratic? Which way would you like to do? Factoring, Kate? Not quite a difference of squares because of this guy.
Let's just go with factor. So we can't
Yeah.
factor?
We can factor, it's just not a difference of squares. Rhymes with almond actor. Oh, what's the common factor?
You really don't get bit on that line and do not totally give it away like that.
Totally pausing. There was one time I was trying to get the class to say, yes.
Nice.
Is this completing a square?
It's factoring.
X minus 4. Because we were laughing. X equals X. Well, I need 8. So like 4. So we have to check all these.
We will in a sec. What are we going to do over here?
Same thing. No, plus 4x is equal to 8. Negative x plus x equals 0. X equals 4.
What do you notice? So do we need to check the values twice? No, we're just going to check them independently.
That is 0. It equals 0. That is right. There's also 0. Oh my goodness.
That's also
It's fantastic.
Do we need to do anything on the other side? There we go. There's a quadratic. That's the hardest thing in the unit, by the way.